Hello. In this lesson I'm going to be looking at burning hydrocarbons. In the previous lessons we learnt what a hydrocarbon was, and we were looking at crude oil as an example of hydrocarbons, and we saw that hydrocarbons were very short carbon chains, tended to be gases, medium length carbon chains tended to be liquids, and the really long ones tended to be solids, and that the shorter the chain the more volatile it was, the easier it evaporated, the more flammable, the easier it is to turn into flame. And the thinner it is, the less viscous, so the long chains are thick to pour. Anyway, enough of that. Let's look at what a hydrocarbon is. A hydrocarbon is made of hydrogen and carbon, and in the last lesson we looked at how they bond together. We said that hydrogen has got an atomic number of 1, which means it's got 1 proton in the middle, and to balance out that positive proton you have a negative electron going around the outside. Because there's only 1 electron, that goes into the first shell here. The first shell would like to hold 2 electrons, and so there is a gap. There's a space here where it would like to have an electron, and so we draw it like this with 1 arm sticking out, trying to hold hands with another atom so that it can fill up that outer shell and be happy. Carbon, we said, had an atomic number of 6, which means it's got 6 protons. So if it has 6 protons, it has to have 6 electrons to balance them out, and the electrons go like this. You have the first 2 in the first shell, that is then full, and then the other 4 then go in the second shell, and the second shell, as we know, would like to hold 8 electrons, and so it has got 4 spaces here. So we draw carbon like this with 4 arms trying to hold on to things, which is why we could have carbon and 4 hydrogens joining together, call it CH4, which is methane. Now what I want to introduce today is oxygen. Now oxygen has got an atomic number of 8, which means it has 2 electrons in the first shell, and in the second shell it has got 6 electrons, balancing out those 8 positive protons, remember that. So in the outer shell of oxygen it's got 2 spaces here, and it's got 2 spaces for extra electrons, so we draw oxygen like that with 2 arms, and this is why we have things like H2O and CO2, but we'll come to that in a little while. Now oxygen, because it's got a double bond like this, it tends to hang around in pairs and joins onto itself. So those 2 arms that were sticking out like that, they turn around and they hold onto each other, and so oxygen hangs around in pairs, which is why you will see it written as O2, and that is called a diatomic molecule. It's made of 2 atoms. Diatomic makes up a molecule, which is a couple of atoms joined together here. Right, so we've done all that. Now we are going to burn some hydrocarbons today. Let me just clear this and have a bit of space. And as you know, in order to burn something you will need some oxygen. You also need a fuel, and the fuel we're going to use is a hydrocarbon. So it's got hydrogen, carbon, and it's got oxygen in it. So if we're going to add all of this together, let's start with methane, which is CH4, which is made of 1 carbon atom and 4 hydrogen atoms. Now to that, if we want things to burn, we need to add some oxygen. Now I've told you that oxygen hangs around in pairs, O2. So I'm going to draw a pair of oxygen atoms here. Now we can add as much oxygen as we like, because we're going to be burning it in the room, and the room is it's got plenty of oxygen in there. So I can add some more O2s if I need to. But what I want to think about is, what can you get if you add hydrogen and oxygen together? What can you get if you add carbon and oxygen together? And what we can get if we add hydrogen and oxygen together, we could make this stuff. Hydrogen, oxygen, and another oxygen can join together, because if we look up here, oxygen has got 2 arms, hydrogen's got 1 arm, so it can join together. So that works, and we will call that H2O, or water. And so we've made one here. I have used 2 of my hydrogens. So I've used that one, and I've used 1 of my oxygens. That's good. I've got 2 more hydrogens left here. I can make another one of those. Hydrogen, oxygen, and hydrogen. So hydrogen, oxygen, hydrogen, and another oxygen. So I have made here 2 lots of H2O. Now I've got this carbon that I haven't used yet. Now remember I said we've got plenty of oxygen. Let's throw some more oxygen in. Let's have another O2 in here, like that. So now I've got 2 lots of O2. And now I've got a carbon, and I've got 2 lots of oxygen. And so I can make, let's see what I can make here. Here's my carbon, here's my oxygen. If I had an oxygen here with its 2 arms sticking like that, and another oxygen here with its 2 arms sticking like that, they can all hold together, and we call that CO2. So here's my carbon in the middle. There's an oxygen there, there's an oxygen there, and I've made CO2. So when you burn something with oxygen, you end up with water and carbon dioxide. Now water, that seems a bit crazy really, because water puts out fire, but this is actually a water vapor. Now I'm going to try and demonstrate this with a fuel. Here we go. Now the fuel I'm going to use here is ethanol, which is made of carbon and hydrogen, but it also has a little bit of oxygen in there as well. And I'm just going to put a little bit in there. I don't really want to put too much in there, so I've got some in there. And all I'm going to do is I'm going to coat the outside of this thing here. So there's ethanol in there. Well, I don't want any spare, so I'm going to pour everything else back in again. So all I've got in this jar is just a thin coating of ethanol on the outside of it. Some on my hands as well, but that's with hand sanitizer in these difficult times. So let me hold that up to the camera there, and you can see there's a tiny little bit of liquid in the bottom there, but give that a good old shake up and put it around the outside, and that should coat it. So there's virtually no liquid in there. Hopefully it's all vaporized. Now there's lots of oxygen in here as well, so I am going to see if I could ignite this, and I want you to watch very carefully because you might see a little flame coming out of here. And there we go. So we got a nice blue flame coming out of there, but if you now look at this here, there's more liquid in the bottom than there was before, and so that liquid is some of the water that has been created during the combustion process here. Now I said water is in a vapor, but some of it condensed and is on there, so you tend to get sort of water vapor coming off. Now it's not pure water, as you can see here. If I just do that, that's actually burning nicely, and you can see that. Now here we've got a nice yellow flame going on here, and I'm going to talk about yellow flames and blue flames in a little while. But what we can see from this, if I don't set fire to the whole house, that should go in a second. It's all gone. Is we had got a fuel. Now this was carbon and hydrogen was my ethanol. There was a little bit of oxygen in there as well. I did a couple of bits, some O2, and I ended up with H2O, which you saw there was extra water in there, and some carbon dioxide. So any fuel that is made of hydrogen and carbon, which is virtually any fuel that you will burn, whether that's wood or oil or anything like that, it's made of carbon and hydrogen, maybe some other bits as well. You add some oxygen, the carbon turns into carbon dioxide, and the hydrogen turns into water vapor. But we have been talking about nice complete combustion going on here. I want to talk to you about something called incomplete combustion. What happens if there's not enough oxygen for all of the carbon and all of the hydrogen to react as we want them to. So I've got here a candle. Candles burn with an orange flame. You saw the bottle that went whoosh a little bit earlier on. That had a blue flame as it came out to start off with. And if you get a nice blue flame, then that means there's plenty of oxygen for all of the carbon and the hydrogen to react with. If you don't have enough oxygen, you have something called incomplete combustion. Now I have got a flask here, and I'm putting it in the flame, and I can see that it's going black straight away in the flame. So I'm going to hold it up there, and you can see there's black on there. It's not burnt, it's actually soot, and if I do that, it comes off, and the soot is on my finger, and that soot is actually carbon. So my candle here is a carbon based fuel. It's got hydrogen and carbon in there, and so I don't know how many carbons and how many oxygens, but we know that carbon and the hydrogen likes to react with some oxygen, and it will make some H2O. It will make some CO2, hopefully. But this has also made some C, just some carbon. That was the soot that's on there. But you can also get if you've got a little bit of oxygen but not quite enough, you get something called CO. So you haven't got enough for 2 oxygens for each carbon, you've only got 1. And that is called carbon monoxide, not dioxide, monoxide. And that is extremely poisonous. And it can kill you. It binds with the hemoglobin in your blood and stops your blood sort of carrying oxygen around your body. Now, we do use incomplete combustion on purpose quite a lot in our lives, because if you have a big roaring blue flame, then all your fuel is used up very, very quickly. And if you're talking about something, say a barbecue, when you're burning some coals, you don't want your fuel to burn very quickly. You want your fuel to last for about an hour so you can cook all your sausages on it. So it's deliberately designed so there's a limited amount of oxygen that comes into that, but the carbon monoxide that comes off isn't a problem because it's outside, and so it all gets lost into the air. The problem is, and this is what some people do every year, and I've seen people do it on campsites, I stopped someone doing it once, is at the end of the evening the barbecue is still nice and warm, their tent is quite cold, so people take those burning coals or the smouldering coals into their tents to keep them warm. And sadly, each year a small number of people do die of this carbon monoxide poisoning because they don't understand the chemistry of it. So we have got complete combustion, plenty of oxygen for all of the carbon and the hydrogen, and that produces water vapor and carbon dioxide. And then you have incomplete combustion. If you don't quite have enough oxygen to go around, you can just have carbon in the form of soot, and you can have carbon monoxide, which is a poison. That's it for this video. One more video in this crude oil topic, which will be a cracking video. So watch out for that one next time. Thank you.